All right, so this is equations containing, equations containing fractions. It's a very brief section. There are some basic skills that are associated with it. So let's get started and see what we can do. If I have 1/7, let me give it a little bit more space. If I have 1/7 times x equals 2, and I'm solving for x like we've done in the past, what we want to do is ensure that we know how to get x isolated when you've got a fraction in front of it. That's essentially the heart of this section. So the way that you approach this is you look at the fraction. Well, I've got a 1/7. That is in my way right now. And what you're going to do is you're going to multiply both sides by the reciprocal, the opposite, the flipped version of the fraction. Why would you do something like that? Why would you do that? Well, the reason why you do that is because we've learned that when we multiply fractions, we always look to see if we can cancel things. And by multiplying by the reciprocal, we effectively are able to cancel out the fraction on whatever side has the variable or whatever it's attached to. So as you can see here, what happens? All of these cancel. They all become 1s, right? And what's 1/1 times 1/1? Just 1, or simply excess left over. Does that make sense, everybody? Any questions about that? So the most important thing that you want to do when you're working through these problems is identify, ID, the fraction in front of the variable. This one right here. What's the fraction in front of the variable? That's what we just did, didn't we? And then the second step is to multiply both sides, not just one, but both sides, by the reciprocal of that fraction. If it's a over b, both sides get multiplied by b over a. Isn't that what we did right here? By doing those two steps, what we do is we are able to isolate the variable. Now over here, now it's just a matter of remembering the rules for multiplying fractions. We know that we can rewrite this as 2/1 times 7/1. And obviously in this case, you could have just said 2 times 7. That would have been fine and ended up with 14. But I'm just writing it out to show everything. Okay? Are there any questions about that at all? Please let me know if you have any questions. I'll be happy to do your problem. You want to get started on the right footing for this section. There's not a lot of problems, but if you struggle with this initial step or multiplying fractions, it's going to be a pretty tough section to get through. Any questions about that at all? Are you okay? Can I move forward? Hopefully you got your first question correct. Let's take a look at the next one, shall we? So this next one, I have -35. Notice how I leave some space here? Because what am I about to do? About to multiply something by it, right? So I leave some space free. Equals 5/11 times x. Why did I leave some space right there? Because I'm about to do this, aren't I? So you're planning ahead of time because you understand that you're about to do these two very important steps so that you can get the variable all by itself. So what do we need to do? Identify the fraction that is attached to the variable, also known as the fractional coefficient, the rational coefficient. Rational fraction that is in front of coefficient, the variable. Okay? Well, that's a 5/11. Our rule says we're going to multiply both sides, not just one, by the reciprocal of that fraction. If it's 5/11, 11/5. And what we do to one side, not that, be careful, we got to do to the other. Okay? Now, why is this important? To reiterate, we understand that with fraction or rational multiplication, multiplying fractions, we understand that this will result in a bunch of cancellation. Now, do you actually need to write this out? No. When you get used to it, you know that by multiplying by 11 over 5, this is going to cancel all this out to become 1. You don't even have to write all this extra canceling out. I'm only writing it for you so that you can see. Eventually, I'm not going to write it at all. I'm just going to mark it out and then put an X or Y or Z, whatever it happens to be. But I do this for you so that you can see the purpose why. It just doesn't disappear. We are actually utilizing skills that we've had from before to eliminate the coefficient in front of the variable so that we can get that variable by itself. Let's rewrite the left side. 11 over 5 times negative 35 over 1. Now be careful. This is times a negative 35 over 1, not subtraction, right? So you got to be really careful about that. Maybe some of you want to put parentheses around it. You don't have to. I just did it so that you can see that I've got 11 over 5 being multiplied by this negative 35 over 1 fraction. Okay, now I'm going to cancel. 5 and 35, they both are divisible by 5. 5 divided by 5 is 1. 35 divided by 5 is 7. 11 and 1 cannot be divided by anything else. Let's rewrite this. After doing our cancellation, I'm left with 11 over 1 times negative 7 over 1, which equals that X. What's the only new thing that we've encountered so far? This stuff. Is this stuff we've done before? Yes. Is this going and rewriting the problem what we've done before? Yes. So there's nothing really new unless you haven't practiced your multiplication of fractions, but you're going to have to because you got a test on that. So this is the only thing that's new here. Everything else is review. With that said, now we can actually multiply. 11 over 1 times negative 7 over 1 is a negative 77 over 1, or simply negative 77. Okay. Anybody got any questions about what I just did there? Anything at all? Get your question right. I hope you are. If you're not, let me know. I'll do my best to answer your question. Again, a strategy for doing these problems is to write my problem on the left side of your page, your problem on the right side, and match up every step. That's just one way. You don't have to do it that way. Just a suggestion. Any questions about that at all? Want me to do yours? Hopefully you got yours right. Can I move on? All right, gotta stop me. Stop me if you need anything. All right, next one. So I've got a negative 5 over 3 x equals negative 30. Why did I leave a space here? Because I'm about to do some multiplication, right? So step number 1 is to always identify the fraction in front of the variable. What's my fraction? It's negative 5 over 3. What we're going to do is we're going to multiply both sides by the reciprocal of that, 3 over 5. Now the question is, Andrew, what do I do with the negative sign? You will also keep it on there. So notice in the previous problems, this 5 over 11 was positive. This 11 over 5 is positive as well. This 1 over 7 was positive. This 7 over 1 is positive. Whatever the sign is, keep it, just reciprocal, flip the fraction. So if it's negative, what you multiply both sides with is going to be negative. If it's positive, what you multiply both sides with will be positive as well. Got it? So the only thing you change is the orientation of the fraction. So over here, I need to also multiply by negative 3 over 5. Everybody got that? Any questions at all? Okay. So now this allows me to start doing some cancellation. 3, 3, 5, 5, exactly what I expected. Now let me ask you a question. Why isn't this a negative x here? You can, but I did something to make sure that it didn't end up being negative. Exactly, and that is why you want to multiply by the same sign. If I had left off the negative sign here, it would have indeed stayed negative, but by keeping it the same sign, a negative times a negative makes it positive, and that's exactly what you need to do. Multiply both sides by b over a, keep the same sign. Keep it. Follow? Okay? So now let's go do the other side over here. That's going to be negative 30 over 1 times negative 3 over 5. Okay, 5 and 30. Can they both be divided by something? Yes, by 5. 30 divided by 5 is 6. 5 divided by 5 is 1. Now, 1 and 3, nothing. Let's rewrite this. X equals negative 6 over 1 times negative 3 over 1. X equals, what's a negative 6 over 1 times a negative 3 over 1? A negative times a negative is positive. 6 times 3 is 18 over 1, or simply positive 18. There it is. Questions about my work? Any questions about your work? Please let me know. Any questions? Please ask. If you're not sure, you need to ask. I can't help you if you don't ask. All right, I'm going to roll on. Okay, next one. The fractions just get a little bit tougher, but it's not that big of a deal. The thing that's going to hold you back is if your fraction work is weak. If you have bad fraction work, it's going to make a big difference in these problems. The truth is that none of these problems are really hard, but they're only really difficult because you're probably not good with your fractions. And of course, you're about to get tested on that. So you need to make sure that your fractions are strong. If you can't multiply fractions, just think about it. If you're wondering why this became this, probably means you didn't do a good enough job in your fractions section of multiplying. Go back, review it, be better, okay? But ultimately, all of this stuff from a basic standpoint, it all hinges on these two new skills. Everything else, just review, okay? Let's look at this one. Identify the fraction. Is it this one that's important? No, it's not, because it says identify the fraction that is in front of the variable. That's the one that matters. There could be a bunch of other fractions in the problem. The only fraction that matters is the one that is in front of the variable, the one that is the coefficient of the variable. What do we do with it? We multiply both sides by its reciprocal. So that's a negative 1 over 5. Let me clean this up just a little bit so we have a little bit more space to see it. So we multiply by negative 5 over 1, and that was 8 over 55. And what we do to one side, we must do to the other. So this fraction was a negative 1 over 5. So we multiplied both sides by its reciprocal, negative 5 over 1. We kept the same sign. Now, let's go do the fraction work, the multiplication. This is the only new thing today for this section. That's it. If you are struggling to finish this out, it's simply because you need to review your fraction multiplication. Okay, go back to that section, go back to that video, and watch it. All right, 5 cancels with 5, and we're left with just r. Because they all cancel, and a negative times a negative is a positive, and they're all a 1. That's it. Now on the left side, 5 and 55 cancel. They are divisible by 5. 5 divided by 5 is 1. 55 divided by 5 is 11. 1 and 8, I can't do anything with. Let's rewrite it. Negative 1 over 1 times 8 over 11. That's what it becomes. None of that is new. If you struggle with it, go back, watch the multiplication of fractions video. Review your multiplication of fractions. Get better at them. Practice some more with them. All right, next. R equals the multiplication of this. Negative 1 over 1 times 8, a positive 8 over 11 is a negative times a positive is a negative, and 1 times 8 is 8. 1 times 11 is 11. That's it. Okay. Finish yours. Make sure your problem is good. Let me know if you got questions. Okay. Next one. Now we get into a little bit of extra combinations of things. Let's take a look. So I have 1 over 8j minus 2 equals 4. Okay, now, if I had a regular problem from last class, we would do something first. We would add 2 to both sides, because we understood that we needed to get all the numbers on one side and all the letters on the other side. All of the previous problems, that was already done for us. The numbers were on one side, the letters were on the other. The numbers were on one side, the letters were on the other. The numbers were on one side, the letters were on the other. This one does not start out like that. We have numbers and letters together. So first we need to move the numbers to one side, letters to the other. So that's why we do that first, just like we would have last class. This is nothing new. So we have 1/8 times j equals 6. Now, we're back to all the other problems. Now, you just do the exact thing that we wrote over there. What is the fraction that's in front of my variable? 1 over 8. Multiply both sides by the reciprocal. I'm going to save a little time and just say 8. Because 8 over 1 is the same as 8. This is a whole number. I'll just multiply by 8. No big deal. If you want to write over 1, you certainly can, but you don't need to. That cancels. Those become 1, and I'm simply left with, which I didn't even really have to write, j. So that's exactly what we were hoping for on the left. 6 times 8 on the right is 48. So just a little extra step that was built on our last section. Once you do this, all of this is the same as before. Any questions about that? Anything? Okay. Anybody need me to do their problem? Let me know. Okay, next. All right, let's look at this one. I've got negative 12 equals 8 over 3 r plus 12. Okay, so first thing, just like the previous problem, I don't have all the numbers on one side and all the letters on the other. I have both on the right-hand side of the equal sign. So I need to move probably this 12 here over. How do I do that? Opposite. If it's positive, we subtract it from both sides. And so that, for me, would be my first step, because I want this 12 to move over here so that I can get started with all the letters on one side and all the numbers on the other, or vice versa. Letters on one, numbers on the other. Okay, what's negative 12 minus 12? It's not 0, it's negative 24. If you got that wrong, just go back, review your addition, subtraction with negatives. Okay? This, of course, cancels just like we expected. It becomes 0, leaving us with 8 over 3 r. Okay. We can now do this. We can now do this. We can now do this. All of the things that are indicative of the previous problems, all the things that characterize this section that makes it new. This is not new. What we're about to do, that's the new part. 8 over 3, multiply both sides by 3 over 8. Okay? What happens here? Well, everything cancels, exactly what we expected. And we're left with just r. You don't even have to write this out if you don't want to, but I write it out still just so that you can see it. But it's the same thing that we've done over and over again. Now for some fraction multiplication. This is negative 24, I'll write it out, 3 over 8 times negative 24 over 1. Okay, let's take a look here. How can we simplify it? Cancel? Well, 8 and 24. 8 divided by 8 is 1. 24 divided by 8 is 3. Now, let's rewrite the problem because 3 and 1 can't do anything. That's 3 over 1 times a negative 3 over 1. So r is equal to, let's just skip a step, negative 9. Now, what's the only new thing here? This. Everything else, review, 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 review. Anybody want me to do their problem? Yes.
You want to tell you?
Sure. Give me just a moment. Let me erase this one. Okay, go for it.
Negative 10
Okay.
equals 7 over 3 r plus 18.
Okay. Let's go one step at a time. I'm going to label my steps so that people can see that we're going to be consistent about the steps. So this was my step 1. What's your step 1?
Negative minus 8 to the other side of the equal sign.
Okay. So you are going to, did you say minus 8 or minus 18?
18 on the.
Okay. Did you do minus 18 on your problem?
Yeah.
Okay, I just want to make sure. All right, good. So notice everybody consistent, right? Same general first step. Step 2, read to me left to right what it looks like. After we,
Negative 18 equals 7 over 3 r.
say that one more time.
Negative 18.
Are you sure? I've got a negative 10 minus 18.
Oh, negative 28.
There you go.
I was
Good job.
always missing the one thing.
That's okay. Did you make that mistake in your work?
Yeah.
Well, then let's keep going. So that's good. Now we already found our mistake. Equals 7 over 3r. Why is there nothing left over here?
Because we took it from the other side.
You got it. Good job. So now we're going to stay in step 2. We're going to stay in step 2 because, as you can clearly see here, everybody, we got work to do there. What do we need to do here in step 2 to continue on with?
Put it over 1.
Put what over 1?
12 negative 48.
Okay, you can do that. That's fine, no problem. But there's probably something more significant, which is what? What do we got to do next?
To flip 7 to 3, right?
Okay, good. So, and that's going to be what?
3 over 7.
And what do we do with 3 over 7?
Multiply.
Good. Just one side?
Both sides.
Good. Great. Now we're still not done with step 2 because we got to go mark some stuff out, right? This one's obvious. We know that's it. So that's no big deal. Those all become 1s and that cancels just like we expected. What about over here though? Tell us what happens over here.
28 and 7.
Good. They're both divisible by?
7.
Good. What does the 7 become?
1.
And the 28?
4.
Great. Now, let's go into step 3 here. Rewriting the problem. Let's rewrite it left to right. Just read it left to right for us, what it looks like when it's rewritten.
3 over 1.
Great.
Times 4 over 1.
Positive or negative?
Negative.
Good. That's a very easy mistake to make, to miss that sign. Continue onward, the right side.
So now it'll just be 3 times negative 4.
Hold on, right side. What's left on the right side? What's remaining?
The R, right?
Exactly. Everything cancels, so that's all that's left on the right side. Great. So notice, very consistent with our other problem as well. Now, before we move on to the next step, what should we look for over here? If we can do what? If we can do what with these two fractions?
Multiply.
Before multiplying, what should we check for? What did you check for here?
Common.
If we can cancel, that's what you should check for here. Can we do that? No, correct. There's nothing to cancel. Unlike my problem, 8 and 24 could be canceled. But over here, there's nothing that we can cancel anywhere. So with that said, let's keep going forward. What's the next line look like?
Yeah, also multiply.
Uh-huh.
So it'd be 3 times negative 4, which would be negative 7 over 1.
Good. Which equals?
Negative
Well, yes, you're right. Which equals what?
1. R.
Good. There you go. Any questions about that at all? That's a pretty complete problem. There's probably going to be a couple more that are harder than that, but if you can do something like these two, then you're going to be in very good shape. They test just about everything. Moving a number over, dealing with multiplication and addition, subtraction with negatives, canceling, simplifying. A lot of different skills in both of these problems. Okay? I would say that the one I did is just a tad bit harder, only because at this step, in step 3, we had another round of cancellation that we had to do. This one's not quite as difficult because there's no cancellation. Okay? Any questions about that? Okay, good. Let's take a look at this next one. All right, so in this problem, it starts out with everything on one side, particularly, or more specifically, the left side. When you do this problem, if we want to make sure that we start off with all the numbers on one side and all the variables or letters on the other, we have a problem. This is not that. So what should we do to get this started? We should move something to the other side so that we start off looking like this, where all the numbers are on one side and all the letters are on the other. What is the most logical and easy thing to move? the negative 24. Why is it the most logical? Because moving 6/5 x just simply looks a little bit more complex. If I simply add 24 to both sides, I'm ready to go. Okay? And again, this isn't really anything new. If you did your previous homework, you did this already. Okay? It's just a little bit more difficult when you happen to have fractions because it can mess with you in terms of your confidence in reviewing and bringing back your skills from before. But that is no different than any other problem. Why do I say that? Because if I said 6x minus 24 equals 0, you would have no problem saying, well, move the 24 over and divide by 6. This only looks more difficult because, of course, you have a fraction with it. So, with that said, now we can go do all the things that we've done before. Nothing new, same thing. Multiply both sides by 5/6, the reciprocal. Okay? These all cancel as usual, leaving you with just the variable. Now over here, which I love, is that you can put that over 1. You can do that right away if you'd like. And then look to cancel. Can we? Sure we can. 24 and 6 can both be divided by 6. 6 divided by 6 is 1. 24 divided by 6 is 4. Let's rewrite the problem. 4/1 times 5/1. I'm moving fairly quickly again because your multiplication skills, you should have those. And if you don't, review them. Okay? And now x equals 20/1 if you want to be very careful and write every step, or you could have simply skipped straight to x equals 20, straight to there. It's just really up to you. Okay? Any questions about that at all? Anybody want me to do theirs? Anybody? You guys got yours right? Yes? Want me to do yours? All right. Okay, let's keep on going. All right, let's look at this one. Okay, 8 minus 2 equals 1/5, y minus 4. Okay, so when in doubt, always make sure the numbers are on one side, the letters are on the other. This is not the case. Also, if you can simplify things on one side and the other, do that first. What can be simplified right off the bat? 8 minus 2. Don't overthink it. It is indeed just 6. So if you can simplify something, go and simplify it. That's really the only little extra difference between this problem and some of the previous ones. From here, it is just like the previous ones. So if I need to make sure the letters are on one side and the numbers are on the other, it's a lot easier to probably move numbers than it is to move letters. That is why I'm not going to move this y term. I'm going to simply move the negative 4. So I'm going to add 4 to both sides so that I can get the letter term by itself and the numbers by themselves. Any questions about that at all? Again, this is just a repetition of what we've done before. And now, same thing. I'm just going to move quickly through this at this point because you guys know how to do this. And so there it is. I'm done actually very quickly in this problem. Same stuff over and over again. Anybody want me to do their problem? Anybody? Let me know. Good? Good? Questions? All right. I'm going to move on unless there's questions. All right, let's take a look at this one. All these steps are lined up. Okay. Now this one looks really tough, but I will tell you that it's not so bad. Especially if you go and simplify things first before you get overwhelmed. The only reason to get overwhelmed is because you don't see that you can combine things first. Go and combine things, you probably already see it. What can we put together before we even do really any major work? You can put those things together. What's negative 10 plus 4? Negative 6. What's negative 1 plus 0? Negative 1. Those are review skills. Those are addition and subtraction, adding and subtracting of positives and negatives. Things we've done before. Now, are we kind of where we were before? Yes. Move the numbers to one side, letters to the other. What's the easiest thing to move usually? Numbers. I'm moving the negative 6 over because it's usually easier to move numbers. When I move the negative 6 over, I'm going to do the opposite. I add 6 to both sides. 5 over 4k equals negative 1 plus 6 is 5. And now it's a matter of just doing all the things that we've been doing for the last 30 minutes or so. Multiply both sides by the reciprocal. Gone, 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 gone. Left with just the k. Can we cancel anything? Let's rewrite it. And so my answer is just 4. Now, anybody want me to do theirs? Sure.
So it's negative,
Go ahead.
negative 11 plus 1 plus 7 over 3k equals negative 4 plus 1.
All right. Let's go ahead and label steps so that we can match up our steps. And we'll work this out together. Okay, what's the first step?
Well, to get all these numbers to the other side.
Okay.
Negative 11 plus 1.
Good, so negative 11 plus 1, we've got to do that one first, right? What does that become?
10. Negative 10.
Great job, excellent. And then the 7 over 3k can't do anything. What else can we do in that first step, looking at what I did?
Move it over.
Not yet. Not quite there yet. Add what?
10.
We're not at the 10 yet. You still have something else to do based on my first line of work.
Negative 4 plus 1.
There you go, good job. So we've got to do that, right? What's negative 4 plus 1? Great, good job. And that is consistent with my first step. Always add and subtract, simplify on each side before you do any movement. That is always the first thing to do. Okay? Now we can do what? Add 10 to both sides. Great. Go ahead, read it left to right. Go ahead and go read left to right.
So it's just 7 over 3k
Good.
equals 7.
Great, excellent. And look at that. I mean, granted, my step 3 has some more stuff in it because we're about to do that, but that's what it was before we did more things to it. Good. All right, you ready for? You let me know when you're ready to do the next thing.
Flip the 3/7 multiplied.
Good.
And then you put it to the other side.
Good job. What can we put underneath the 7? Yeah,
One.
good job. All right. What should I mark out over here?
7. Uh-oh, yeah, and then the 3.
Good. Leaving us with just
1. Well, no. it's your
1
K.
and K. So you could write a 1, but we don't need to, right?
Mhm.
But that is ultimately what's there. You're right. Okay, let's go do the other side. What can I mark out?
7.
And what do those become?
1.
1s for sure. We probably should write them out. Why don't we rewrite what this becomes? Tell us what this becomes. Rewrite it.
It goes 7 times 3.
Oh, careful.
Wait, 1 times 3.
Why don't we rewrite it? I know what you're saying, but let's rewrite the problem.
Oh.
Okay, let's do that. Now,
Yeah,
go ahead.
it's 1 times 3.
Okay, which is?
3.
You want to be done there? You're right. I just didn't know if you were going to do 3/1 and then make it 3. It's
I
fine.
was
Okay, good.
okay, thank you.
And there you go. Both of those problems are pretty equivalent. There's not one that's harder than the other. They're about the same level of difficulty. But they're both difficult and not quite easy. But most of it is, again, review stuff that can cause a student quite a bit of difficulty if they struggle with adding, subtracting, positives and negatives, not knowing the addition rules to move things around, multiplying fractions properly, our new skill, simplifying. Those are all things that we've built up, but if you forget them, you're going to get stuck and not able to finish the problem. That was very good. Any other questions? Okay, all right. All right, let's take a look at this one. Now this is, to me, the hardest stuff, because now what we see is we see a combination of addition, subtraction with fractions, and the division. This is tough. So I definitely think that if you can't do this, I don't blame you. And you're just going to have to work a little bit harder with it. This typically brings in the most difficult type of fraction work, which is addition, subtraction. Question? No? Okay. You're fine. So, follow along. The same general steps are there, but now you've got a fraction there. What did we always ask? Simplify, move the numbers to one side, letters to the other. Well, I've got letters and numbers. Numbers. This fraction here, it's a number. So that 3/4 is like this -10. It needs to go. It's positive, so we're going to need to subtract it. And that is the first difficult thing to kind of wrap your head around. Is it the same as what we've been doing? Yes. But is it different as well? Yes, because it's fractions, and that's what messes people up. So there's my first step. Let's go to the second step. Obviously, this is going to go away because that cancels out, leaving us with just 9p. Now, what I have over here is a 7/8 minus 3/4. Now, what you can do here is, if you want, instead of putting it here, come off to the side and do the side problem. Isn't that true? 7/8 minus 3/4, it's a side problem. In the past, we don't have to do a side problem because that's easy to do. But now I've got a whole other problem of addition, subtraction with fractions that complicates the matter. What do we do with addition, subtraction? Common denominator. And that's, again, why this is hard. What's the common denominator? 8 times 2 times 2. 7/8 minus 6/8. If you're rusty with that, I don't blame you. There's very few people that are extremely strong with addition, subtraction, and fractions. But if you look at that carefully, you realize we've done it before. We had a whole section on it. So go back, review the addition, subtraction with fraction section if this doesn't look familiar to you. I got a common denominator. What I do to the bottom, I do to the top. And now, 7 minus 6 over 8, isn't that what we did before? Leave the common denominator, add or subtract the numerators. What's 7 minus 6? 1 over 8. And so that is how we get 1 over 8 right here. You guys follow me? It's not easy. This is actually extremely difficult. So if you're not immediately getting it, I don't blame you. And it's probably because there's so many different things going on at the same time right now. It's hard. Okay? Ultimately, review, but doing it all together, that's what makes it tough. Now, I am going to come down in step 3 and just rewrite this, okay? I'm only doing this because I don't want you guys to get all confused. I'm rewriting it so that there's no confusion, okay? Take a moment, pause, and watch. If you're doing a great job on your own, fine. But if you are learning with me, then pause and just watch. Because this is the first time we've seen just a whole number here. And that can really throw off some students. All this time, what has been in front of our letters? So now a student's easily going to get confused. What do I do? Well, why don't we look at it this way? How's that? Does that help you know what you need to do next? Sure it does. Multiply both sides by what? 1 over 9. You guys follow me? And that's why I didn't want to write it all up here. I want to come down one more step, show you, so that you don't get too confused or as confused. So let's recap what I did there. There was a whole number here, 9. That 9. I just put it over 1 so I could clearly see that it also can be made to a fraction. And the same principles that we used before, and the same principles that we used before can also be applied in this case. No different. Cancel, cancel. Good. Leaving us with just P. Anything to cancel? No. 1 over 72. There it is. Not easy. Tricky. Definitely tricky. But doable. Take your time, do it. If somebody wants me to do theirs, I'm happy to. Let me know. Anybody want me to do theirs? Okay? We'll move forward. All right. I'm going to give you guys a break. Don't worry about this. If you want to do them, you can. It's not really tough, but that's it. Okay?
Do it.